very small example of calculating that equation. Sorry. Of calculating this here, okay? So everything I described can be done, in terms of that calculation. Here's an example, here's another example, a separate example. So you're going to ask to form PSHA for a site with a single struct slip fault. The source is expected to produce an earthquake of magnitude 4 or greater every 5 years. So that means this value 4 or greater every 5 years. So we're only interested in values of magnitude greater than 4. So remember this. So basically for this particular source, the probability that magnitude greater than 4 is going to occur is 0.2, right? It's the annual exceedance probability is 0.2. It's 1 every 5 years, okay? And then the distribution of those magnitudes is shown in the histogram below. So here, this is the magnitude distribution given to you. You've got 4 of them. We're interested in 4 magnitudes. Not so much bins here, but 4 magnitudes. And then the source site distance is distributed as indicated in a separate histogram, also given below. The source site distance. Okay. Assuming magnitudes 4, 5, 6, and 7 can occur at these distances, and using the simplified ground motion prediction relationship here, develop a seismic hazard curve for the site. Use PGA levels of 0.05, 0.1, 0.2, 0.3, 0.5, 0.7 for your computations. And then once you've got your hazard curve, then you want to use that hazard curve to solve to answer these questions here. So, I've done that. And I think it's well worth your while to do this question because it's very simple, but you'll come up with the spreadsheet or the calculation that you need to be able to do your assignment. And it's a very simple example. So here, that's the description. So I basically end up with doing something like that. Okay. So for each of the magnitudes, okay, I've got every combination of magnitude and distance. I calculate my peak ground acceleration for each of those combinations. I calculate the standard deviation. Then this is for one target acceleration. Okay. And that's it. This is the. Okay, I've got to convert it into log. This is a log normal space, so I've got to convert it all into log normal. Okay. Once I've got that, and that, I can calculate my Z value. Once I've got my Z value, I can calculate the cumulative probability. Once I've got the cumulative probability, I calculate the probability of exceedance. Okay, and then I multiply that. This is the one I'm after. I multiply that by the probability of this distance occurring, multiplied by the probability of this magnitude occurring, and I get the total. Okay, so that times that times that is that, and I do that for all the combinations. Okay, sum those. Then I multiply all of that by the threshold rate of exceedance, which is 0.2. So that's the probability that a magnitude greater than 4 is going to occur. Okay, end up with that. And I do that for each of the target accelerations. Okay. Okay, so that's what and then once I've got that, annual exceedance, annual rate of exceedance, I've got my seismic hazard curve. Now once I've got my seismic hazard curve, then I can answer these questions. Remember last week we used the Poisson's distribution to answer these type of questions? Okay. So that's a lot to digest. Okay. Don't be daunted by it, because I'll go over it again. I'll go over most of these things again in the first half of next week's lecture, I think. But maybe what you could do is just look at that. If you could, it's going to help you, right? Just look at this question here, this one here, this one here. Okay, and then. You can use that if you did it by hand, right? You use that, right? So just look at that question there, and then look at the answer that I'll put up online for it. Okay, that spreadsheet there, and see if you can come up with the same values. Okay, do that for your homework, and that's basically, if you can do that, that's kind of you're on the way to being able to do assignment 1. Okay. Now, just in terms of, just in terms of just notes on that. You do that in Excel. Okay, so this is, remember for our Z value equals, say, X minus the mean over the standard deviation. So this is our, in terms of the context of our problem, this is the target acceleration, and this is our mean acceleration from our ground motion prediction equation. Okay, this is our standard deviation. So in this case here, we've got Z. So this is a target acceleration, 0.05, and then I'll take the log of that, because you can see all of these are in the log normal space. So to keep it consistent, we have to take the log normal of this. Okay? So basically for the first one there, what I've calculated there, the Z value will equal minus 2.996 minus that minus 2.562 divided by the standard deviation, which is 0.8. Okay, and that's my Z value, and that is this thing here. Okay, once I've got that Z value, I want to calculate the cumulative probability, right? So remember, you could do it using those charts. Remember the charts that we've got? I've showed you the, you could do it using this here. Last week I showed you those charts. You do it using these charts here, right? You can calculate that. An easy way to do it is probably to use Excel, which obviously I've done. So Excel, what would I do in terms of Excel? You want to look at the formula normal standard distribution. So look at this, the formula to calculate the probability, the cumulative probability. So remember we're looking at the cumulative probability. This target acceleration, we're looking for this, cumulative probability. You look at Excel, you'll have, I think it's this equation here, norm dot standard, okay, dot S distribution, dot dist. When we use that, you've got to get it, so you type that in, so norm dot S dot distribution, dot dist, and then you put in, I think, Z value, and then you put in truth. And why you put in true, you can search it online, but why you put in true is that parameter there just says that you want to calculate the cumulative probability up to that point. Okay, so that's what I've done to calculate that. Okay, but then what are we interested in? We're interested in this here. We're interested in that being exceeded. We're interested in that. And so that is 1 minus that gives me that. Okay? And then we multiply that times the distribution, the probability of the distribution times the probability of the magnitude, and we get that. So yeah, I think for your homework, if you've got, yeah, it's going to help you, okay? Because if you do that, then the assignment's going to be a lot easier, okay? So just try and do that for your homework, just this one here. Try to get that spreadsheet going. If you've got any problems with the spreadsheet, or to copy that spreadsheet and to come up with this hazard curve, we can discuss it next week, okay? And then next week, once we've got that information in your hazard curve, then we can calculate, we can solve, using Poisson's distribution, we can answer these questions, right? But you can have a look at that as well. I mean, I'll upload this onto Moodle, and you can look at the answers as well. Because what, so here, so I mentioned, and if you don't understand, we'll go over them a little bit next week. But, so answering these questions here. So for this one, using the PSH seismic hazard curve, calculate the probability that an acceleration of 0.1 g will be exceeding in a 30-year period. These two questions you can try. We'll have a look at the solution, and these questions you can have a look at the solution too. And you'll remember from last week, when we were talking about the situation where we had at least, so determine a magnitude having 10% probability of being exceeded at least once in 50 years, we have to come up with this derivative of the equation, right? So that's the original equation, probability of exactly, when you've got exactly, you use this equation. When you've got at least, you have to use this derivative of the equation. And you can look in the notes on how that's derived, okay? So that's 1 minus the probability. When you talk about at least, it's 1 minus the probability of the event not occurring. So I know that's a lot to digest, but I'm sure, 100% certain, in a couple of weeks, you'll be expert in it. Okay? So, but yeah, try and do that last assignment.